Hello students, here you see two sketches, both the engines and both the sketches of a reversible engine, but this is a reversed Carnot engine. Reverse means, its direction is reverse, right? So here heat engine, this is QH, QL, I have explained all that. But now here we have just reversed. So this is a reverse Carnot engine. Efficiency of this engine, Carnot engine, is TH minus TL upon TH. I don't have to tell you that, but I will write this nevertheless. Efficiency of Carnot is TH minus TL upon TH. Efficiency of this reverse Carnot, right? What is that? Now see, reverse Carnot means you are, the entire operations are reverse, but still it's an ideal, you can call this as heat pump. You can also call it as refrigerator, right? I mean, it's not refrigerator, it's an abstract form of an ideal refrigerator, abstract form of an ideal heat pump. Now, first we will understand difference between heat pump and refrigerator. I think you must have studied, but nevertheless. See, heat pump, the purpose of heat pump is to heat something. Imagine you are in a cold country, somewhere in cold region, right? Very, very low temperature, minus 10 degrees Celsius, suppose. And if this is a room in which we are staying and we want to maintain the temperature of the room, let's say at 22 degrees Celsius, whereas surrounding temperature has dropped to minus 10 degrees Celsius, right? So, what will happen? The heat will continuously leak from this room to the surrounding. Because let's say this is our room and we say the temperature I say is 22 degrees Celsius. 22 degrees Celsius. By the way, there is one important point which I didn't say is these temperatures TH, TL minus TH are in Kelvin. Okay? Efficiency of Carnot engine is also expressed as TH minus TL upon TH, but the temperatures are in Kelvin. This is something which I didn't mention, I should have. Okay? But right now let's say this is something on body which is at 22 degrees Celsius. In Kelvin it will be 22 plus 270. And surrounding temperature, I said it is minus 10 degrees Celsius. Right? Minus 10 degrees Celsius. So what happens is heat is continuously leaking from the room to the surrounding. Okay? And then we will just freeze to death. But if you continuously supply the heat to this room and at the same rate as that of the heat leaking away from the room, then the temperature will be maintained at 22 degrees Celsius. But for that, heat has to be given to the room. From where the heat will come? You can run a heat pump, lift the heat from the surrounding. The surrounding is at minus 10 degrees Celsius. So you imagine a heat pump which is taking the heat from a low temperature body which is at minus 10 degrees Celsius, and of course you have to, this W. I'm so sorry for this mistakes I make. This is W is work input, okay, work input. So, but remaining, this is heat pump or heat, we are talking about heat pump. So, heat is to be lifted from surrounding which is at minus 10, this becomes our sink. Lift the heat from the surrounding and give it over here, okay. For that you have to consume some work, right? So this is a heat pump, you will consume electricity, you will run a, all that system, and work is supplied, heat is taken from the surrounding and given to your room which is acting as source in a way, because we want to maintain it at 22 and heat was leaking to 10, this is minus 10 surrounding, okay. So in this case, now if you want to find out its efficiency, now what do you mean by efficiency here? Efficiency is output upon input. So what is the output for this pump now? Pump output is the amount of heat you are giving to this room, that means this source here, okay, amount of heat or the rate at which it is given, whatever. So this is QH. So that will be QH upon W, right? QH upon W. So you can say that, and that will be called as COP, coefficient of performance of heat pump, which will be QH upon W, right? It will be QH upon W. And we are talking about Carnot here, Carnot engine here, and then this can also of course be written as QH upon QH minus QL. You can think about it. Instead of W I have written this QH minus QL. Okay. If it is Carnot engine, as we are assuming Carnot heat pump, then this expression can be written as TH upon TH minus TL, right? All that you have to do is QH has to be replaced by TH, QL has to be replaced by TL. Then this becomes expression for Carnot heat pump. It is expression for Carnot heat pump. Okay. Now, suppose you think, consider this. Now let's consider this to be a refrigerator. It's a refrigerator. What is the function of a refrigerator? In the household refrigerator, you keep food and you want to maintain some temperature there, like lower than the surrounding. So, you know, it's if you don't do anything, what happens is the temperature of the inside food will keep on rising because heat is continuously leaking from outside. You are opening the door of refrigerator. Even if you don't open it, there is slow leakage of heat because of, you know, surrounding temperature is higher. So if you want to maintain the the cabinet temperature at a lower, a fixed constant value of some temperature lower than the surrounding, then you have to continuously extract the heat from the cabinet and throw it outside. So if you touch the back side of refrigerator, it's warm. Why? There is condenser, heat is rejected. Heat is taken from inside and thrown out. That's why you feel the warmth over there. Anyway, we are talking about ideal refrigerator. It's Carnot refrigerator here. So here is what we want to do is, this is our low temperature, this is surrounding. Let's say now it is everything changed. So this is our cabinet. We want to maintain that lower temperature. Surrounding is at a higher temperature. Continuously heat is leaking inside. Okay, continuous heat is leaking inside. So if you want to maintain the temperature at constant value of TL, then the rate at which heat is leaking inside has to be exactly, that has to be removed continuously at the same rate. So if QL is the heat leaking in, this QL is lifted by this refrigerator. So refrigerator is continuously lifting the heat and it is giving it to the surrounding. That's we can consider it as source. So it's reverse. Okay. So now this is working as a refrigerator. So for a refrigerator, again, coefficient of performance, COP of a refrigerator is output. What is the output now? In heat pump, it was how much heat you were giving to that room which you wanted to keep warm. That becomes output. Whereas here, it's refrigerator, it's cabinet from which you are extracting heat, right? So how much, at what rate you are taking out heat? That is your output. So now COP of refrigerator is QL upon W, right? It is QL upon W. W is the input. Now you can write this expression. Okay. So this can be written as, now see QL, W is QH minus QL. So I can write this as QL upon QH minus QL. And if this, because this is ideal refrigerator, that is Carnot refrigerator. That means I can also write this as TL upon TH minus TL. TL upon TH. So this is valid only, this expression is valid only if the refrigerator is Carnot refrigerator. Okay? Right. Now see, by logic, you can say that efficiency of Carnot engine, you said for the given, Carnot theorem, for the given other engines compared to other engines working within the same temperature limits, efficiency will be maximum. Similarly, for a Carnot heat pump, right? For a Carnot heat pump, input energy is W, right? Or refrigerator, input energy is W. So if you compare a Carnot refrigerator with any other refrigerator operating between the same temperature limits, the work required for Carnot refrigerator for the same amount of heat extraction will be least, right? So least work will be consumed if you run a Carnot refrigerator or Carnot heat pump, right? Compared to other refrigerators and pumps which are working between the same fixed temperatures of source and sink. Okay. So when you say In the exams, sometimes the question they ask you, they give you some values, QH, QL or temperatures, and they will say that find out the least work required for a given heat pump or refrigerator. Then you are supposed to treat this refrigerator or a heat pump as Carnot refrigerator or Carnot heat pump. They may not, in the exam, it may not be directly told to you that treat this as a Carnot refrigerator or treat this as a Carnot heat pump. They might say, or the examiner might say that find out the least work input. That means treat this as Carnot refrigerator, treat this as Carnot heat pump. Or if you have heat engine, in the heat engine, they might ask you, if it's a heat engine, find out the least heat rejection. If you are given temperature limits, source and sink, and if you are told that find out the least heat rejection, then you are given the hint that you are supposed to treat this as Carnot heat engine. Because in Carnot heat engine, its maximum efficiency compared to other engines working in the within the same temperature limits, so heat rejection is going to be least. So that's what you are told. Okay. So now you are in a position to solve all kinds of numericals on Carnot engine, Carnot refrigerator and Carnot heat pump. Thank you.